Hello, good afternoon. Thanks for having me. My name is Luciano Resende. I'm working as a data science platform architect in the Spark Technology Center in IBM in San Francisco. I have been contributing to open source for a long time and recently contributing in different areas around the Spark ecosystem. If you need to contact me, here are some of the references to reach me via email, Twitter, or anything you want. So I work in IBM, and usually when I talk about IBM, people will think a lot of proprietary software and things like that. But IBM has been working in open source for a very long time. We are one of the founders of the Apache Software Foundation. We have been contributing to the Apache Software Foundation for a long time. We have over almost 200 committers available there. We also contributing to over 77, I think 80 projects right now. Not only that, we participate in a lot of community steering. So some of the examples here is AMP Lab, Raise Lab, the Scala Center, all those things that are very deeply, in this case, related to the foundation and creation of Spark as a technology. We also have a customer council that we aggregate, we collect, talk with a lot of the customers that are using Spark in production today, not necessarily IBM customers, just folks from the industry. And we try to leverage that to take information and use cases and problems that they are seeing or good things that they are seeing in the Spark ecosystem so that we can address them or make sure that the best practices are known around the industry. And one of the things that IBM did by embracing Spark is created the Spark Technology Center. The Spark Technology Center was founded in 2015. We are a team that is committed to open source. We don't have any really involvement or running in terms of product life cycle. We really contribute and we build everything onto the community, into the open source. And the mission was basically to get the Spark and the Spark ecosystem ready to enterprise level of usability and usage for the enterprise customers that we have. So today I'm going to talk a little bit about IBM Data Science Experience and IBM Analytics Engine. I mentioned I'm not bringing a product vision here, so it's just an example of an analytic platform. What are the challenges that you see when you're building on an analytic platform? And what are the things that we did to solve that? Basically, the creation of what we call Jupyter Enterprise Gateway, which is a new open source project that helps you build your analytic platform. And also going to give you a few references if you want to learn more about the project, start using that in your company or contributing to that. I hope many of you guys have either heard about the IBM Data Science Experience or have used it, for example, Jupyter Notebooks. The Data Science Experience basically brings you an experience that promotes the data scientist to become more productive. It gives you the necessary tools, integration with data, and content. But when we look, the data science experience is really based on open source. We bring you Jupyter Notebooks, and for those that are not familiar with Jupyter Notebooks, it provides you a way for interactively building applications. That's today what we are seeing as one of the main development environments for data scientists. They provide ability for you to start building your algorithms. You can document them together with your application. You can have text or, let's say, code there that gets executed in certain points. And those code might be bringing data back where you can use the components to do visualization of that data. If we look internally of what a Jupyter Notebook platform architecture has inside that, so you have the UI that will run the notebooks that will run on the web browser on the client side. those notebooks are being served by the Jupyter Notebook server. And when you have the cells that gets executed, basically what is happening is you go into the server has what we call kernels. Those kernels are responsible for executing the code, and usually also for the abstraction of like what type of language you're using or scripts that you're using. Let's say Python will have a kernel for Python, Scala will have a kernel for Python, and go on. And those kernels needs to be running somewhere so that it can perform the activities and return you the results in a very quick way and secure way. So just follow up, just a quick thing. If you guys interested in just trying Jupyter Notebooks, trying the data science experience, just go into this link. It's going to be as a reference, but you guys can take a look at that later on. So I mentioned we have those kernels, and those kernels needs to be executed in a runtime engine. In the case of the data science experience, we recently announced the IBM Analytics Engine. That's what's powering data science experience. It basically is a computing engine based on Spark, based on the Hortonworks distribution that we use. And the idea behind that is we need to come up with something that was very flexible and start addressing the different usages that we were seeing with the adventure of being more and more data scientists on the platform. And I'll talk a little bit more of the differences there. So just some information of the characteristics, but basically more flexible, based on open source. But if we generalize this into more like what an enterprise cloud analytics platform characteristics are, we will basically see a large pool of computing resources. So you have a big, let's say, Spark cluster. It can be running internally into your, let's say, enterprise cloud, or you can be using a public cloud, or even like a hybrid cloud. Usually you have data available in the cloud as well, so like data lakes or like in an object storage. It doesn't need to be co-located with the computing engine. We are seeing a lot more trending on separation of the data from the computing engine. Consumers are distributed. You can have the data scientists running notebooks on their laptop, or let's say as data science experience has, they might be coming just as a different pool of on the cloud as a different service. And those are all connecting to the same computing engine where you have like all the expensive hardware, you're sharing expensive resources, let's say like GPUs and things like that, that it's not worthwhile to have in each kind of like available for each data scientist laptops or desktops. And one thing that we see a lot with the adventure of the data scientist is that there is a different resource utilization pattern. When we were looking, like for example, old times with batch jobs, let's say you have a job that takes 2 hours to complete. During those 2 hours, you were using all the resources that got allocated, and then you're done, and then those resources are basically freed up and it can be used for different jobs. In data science, it's a little bit different. The data scientists will come, they will launch the notebook. Those notebooks, because it needs the kernel, they will allocate the resources for that kernel. But it's an interactive development process. You will tweak a little bit the algorithm, or let's say a paragraph, you execute that, you get the response. Maybe it's not the response that you need. You need to think a little bit what is wrong or what you need to do. And then you go and try again. And maybe you got a little bit tired. You went to drink some coffee, and goes by like 2 hours where the resources are still allocated, not available for other jobs. And you need to basically do something about that. So that's also one of the things that we had in mind, or we are seeing as a shift for like with interactive development in a platform. So we started looking at the current state of the art, what was available as open source components, what we could have been using for building this type of platform. But the thing is that the Jupyter Notebook originatedly from kind of like an evolution from like Python shell, and then came to like, let's do a web UI for that. And the side effect of that is that a lot of the tools that are available around Jupyter ecosystem are kind of like single user, not necessarily very secure in the sense of like for multi-tenancy. And those kernels that we talked, which was responsible for executing all the code, were all available as a local process together with the Jupyter Notebook. And that was not scaling very much when you want to support, let's say, hundreds or thousands of data scientists on the same platform. Even with that, we have seen different approaches for trying to get that implemented as an analytic platform. We have seen people try and share clusters, and what happens is you have to run, let's say, something that will enable a couple of different users to access that same platform, but the side effect is you will have those running as a single user in things like access to data, let's say HDFS folders and things like that will be shared across the different users, and that is not optimal. We also seen different approaches where basically you need to do multi-tenancy. You have 10 users, so we're going to create same environment for 10 different users. That becomes expensive, very hard to maintain, so it was not really like the solution for us. And that's how the Jupyter Enterprise Gateway came to be, basically trying to come up and solve all these problems for building an analytic platform. In summary, like in a paragraph, what is Jupyter Enterprise Gateway? It's a lightweight, multi-tenant, scalable, and secure gateway that enables Jupyter Notebooks to share resources across an Apache Spark cluster, AMI, and enterprise cloud requirements. So when we were developing this and we started at the beginning of the year, we had mainly 3 themes in mind for building that project. We want to have optimized resource allocation. So one of the things that we mentioned, those kernels were running locally. And by doing that, you have the constraint of the resources available on that machine enabled to scale for multiple users. So if you only have, let's say, 10 users and you have 10 gigas, you can only have, if you have 10 gigabytes of like memory, you will only be able to have, let's say, 10 kernels started, so 10 users using. But even though you had, let's say, 200 machines on that cluster, so that was one of the bottlenecks. So we tried to start running all those kernels in a cluster mode. By running cluster mode, you get the driver and all the execution happening on the cluster as a container on Yarn. And so you don't have the limitation of that single machine anymore, and you can use all the resources available. I mentioned in this case Yarn. Yarn was the first one that we had in mind for cluster management, for resource management, and mainly that was driven for some of the requirements internally. But we understood that people on the community were using different ones. So we had, let's say, Kubernetes. People were using Mesos. So we made the resource manage layer very thin and very pluggable. So it's very easy to start adding different ones. Enhanced security. When we talk about cloud and a shared environment, I think one of the requirements that we have, particularly internally in IBM, is that all the node-to-node communication needs to be properly secured. So that was one of the key things that we had in mind. We wanted to make sure that all the sockets communication between the kernel and the notebook, everything gets properly secured. We enable SSH channels for some of the sockets and TLS for encryption, basically, for any other HTTP communication that was happening. We also had the ability. We also had the requirement to provide multi-user, and in this case, we wanted to support the user impersonation. We leveraged Kerberos to do that, and by doing that, we start having a lot of like benefits. For example, the users will then access their own HDFS folders properly. Properly secured for their ACL that was configured by the administrator. And also you will see a same user ID basically being run if you're running a batch job or if you're running interactive development through notebooks. In terms of like kernels that we supported, we aim not to do any kernel modification, but the 3 languages that we were seeing mostly use it, so we give a higher priority for those. We're basically for data scientists, we were seeing Python and R, so we have tested and basically supporting Python with Spark 2x using the IPython kernel. We also implemented things to get the time to be running things more quickly, particularly if you're not using Spark at the first paragraphs or the initial paragraph. So we did what we call the Spark context-delayed initialization, which gives you a better startup time and only restarts some of the Spark dependencies when it's needed in development time. For Scala, mostly around data engineers, but I think there are some data scientists that are also familiar or comfortable with Scala. We have been using PyChetori for that. We also have implemented the Spark context-delayed initialization there. And for R, we have looked into IR kernel. So I mentioned about the resource constraints that we are having by one machine and by running those processes as local. And this is the graph that really explains that. So if you look here, no matter like how many nodes you are having, because you are constrained about like one edge node, for example, we were seeing that the number of kernels that you could support was very constant. And no matter if you add more nodes, you are not having scalability there. By going to Yarn cluster mode and being able to use all the resources on every node, we basically had a very good scalability here. And the more nodes you add, the more kernels and more data scientists you could support there. So in a quick summary of capabilities that we implemented with Jupyter Enterprise Gateway, so kernels running remotely in a cluster mode, pluggable kernel lifecycle management, enhanced security in multi-user leveraging using impersonation and Kerberos. It seems like a lot, and people usually will say, well, this is the first release, maybe it's kind of a code that is not completely mature or completely stable. I wanted to basically mention here that we have built on solid foundations, so the way things happen on the notebook stack, you basically start utilizing some of the basic layers and extending those. So we extend Jupyter Notebook Server to enable some of these capabilities. We also started extending Jupyter Kernel Gateway, which was doing partial of the functionality that we need. And on top of that, we built the Enterprise Gateway. So, and also on top of that, we have been using this internally. I mentioned the IBM Analytics Engine. Analytics Engine already have the Jupyter Enterprise Gateway, and that's what is used for DSX, for example, to connect and use the resources from the Spark cluster that is behind the engine. If we look into a system kind of like diagram here, we will have like clients running either like, let's say, DSX or Jupyter Notebooks. Those will be trying to start new notebooks, new kernels. It goes to the Spark cluster. There is a security layer that will make sure that the user is authorized to use the cluster. One example of that security layer, let's say in a Hortonworks distribution, is like in the Knox component. Once you get authorized, the Enterprise Gateway will manage the life cycle of the kernel. So if you get a request to start a kernel, you get a Yarn container where the Jupyter kernel will be launched with the Spark driver, and then you have executors associated with that. If another users come, you will see that you'll have a different container owned by a different user. So you basically the same user that is on the client side is getting propagated all the way to the process that is started on the server side. In terms of like roadmaps and things that we are looking for the future, these are some of the things that we discussed, not necessarily a kind of set in stone roadmap. If you guys have specific feedbacks or specific areas you want to talk to, let us know. But one of the things is we're going to be able to expose kernel configuration profiles. We understand that data scientists will be running multiple jobs, and those jobs might have different requirements in terms of like resource utilization. And I mean by that memory or number of works. But we also understand that if we give the completely flexibility to the user, we might see those users that will just try to get the whole cluster for them. So we want to establish some profiles where, in conjunction with the administrators, you define what a small, large, medium, or you name it, profile it is, and then the data scientists can basically utilize that when they start the kernels. And we also, like, the administrator can identify what groups of users are allowed to use those profiles. We want to bring up an administration UI where it gives the administrator ability to see what are the kernels, see if they are running idle for a long time, ability to start and stop those kernels, add resources for other resource managers. One of the ones that we are seeing as very hot is the Kubernetes. So that's most likely the next one that we'll be looking into and providing support for that. Also, user environments. We understand that different applications will have like different requirements. We might want to integrate with, let's say, conda environments, Python environments, or what is coming in Yarn. The next version of Yarn is basically just support for containers, where maybe you define the container, all the dependencies, all the things that you need, and that is what we will support for running. So we're looking to those for a future release, and also ability to do high availability. So if one of the enterprise gateways for some reason crashes or has a problem, you can definitely go through the other. You will reconnect to the same kernel that is running on the cluster mode on the Spark cluster, and you have all your session maintained and available for you. So no loss there, and no service loss as well. So in a summary, we have a landing page available in IBM code. We are already part of the Jupyter incubation, so our source code are available in the URL that you see there, Jupyter Incubator Enterprise Gateway. We have all our documentation available. Currently, we have a 0.6 release. Most likely tonight, you will see the 0.7 release coming out. So take a look at that, try to use, provide us some feedback. And if you have any questions, please let me know. And thanks for having me.